In this video, we're going to learn about function-like macros in C. So function-like macros are sometimes called parameterized macros or macros with arguments. And they're in contrast to object-like macros that are often used to create constants using the C preprocessor. So for example, if we say $sign define max20, here we've defined an object-like macro called max. When a C program is compiled, compilation occurs in different phases. And the first phase is the preprocessor phase. What the preprocessor is going to do is look at our source code and replace all occurrences of max with 20. So for example, if we said printf max $d \n, and then here we have max. We can save this, compile our program, and then run it, and we'll get max 20. And what's going on is that the compiler, during its preprocessor phase, replaces max with 20. Now, oftentimes these object-like macros are used as a type of constant value for our program. For example, we could define pi as 3.14, and then we could write out pi wherever it's needed in our program. We can also do things like this though. We could say number define print, and we'll say printf print this. Now, if you're used to using these object-like macros as a way of defining constant values, this might look a little bit odd. But really what's going on is that the preprocessor is going to replace every occurrence of print with this call to printf. So if we just put print here, like this, and save it, we can compile our program and run it, and we'll get print this. And this looks pretty odd because we don't even have a semicolon here, and yet it's working. The reason is this code here, this text, is going to be copied and pasted here by the preprocessor phase of the C compiler. We can actually see the effect of that phase. What I'll do is run the compiler again, but this time I'm going to have a special option, -E. And again, I'll output a file called D, and we'll compile d.c. Let's actually open that D file now. So we'll open up D, and instead of it being an executable, what we're going to get is the end effect of running the preprocessor down here. So we can actually see what our program looks like after the preprocessor is run. We can see that max was replaced with 20. We can see that print was replaced with printf, print this. Now we can also create macros that accept and use arguments. So for example, we could say here, number define inc x plus 1. And this is a macro that actually accepts an argument. What we could do is say int a is equal to 2. Then we could have a is equal to increment a. Then let's output a. We'll printf a:\d \n, and we'll output a. If we save this, compile our program, and run it, we get A3 here. And this is what we call a function-like macro, because it's a macro that behaves a lot like a function. Let's actually compile our program again with the E option, just so we can see the result of the preprocessor. So if we look at this line here, we have A is equal to A plus 1. So again, what's really going on is effectively text replacement, where here, inc A is going to be replaced with A plus 1 when this macro is run by the preprocessor. So it's really still effectively just text replacement that's going on. Now it's really important that there's no space in between the name of the macro and the beginning of the parameters here. If we put a space here and save it and try to compile our program now, we'll get a compilation error as a result, because basically this looks like an object-like macro now. So we have to take away that space. We can create function-like macros that accept two arguments. So for example, let's create a function-like macro to compute the area of a triangle. We'll say area, base, comma height. And we'll have 0.5 times the base times the height, because the area of a triangle is 1/2 the base times the height. Now we can use this macro to compute the area of triangles. So for example, we could say int base 1 is equal to 20, int height 1 is equal to 20, and then int area 1 is equal to area base 1 height 1. And we'll use our macro here. Then we could print out the area. So we'd say area 1 colon %d \n, and we'll output area 1. So we'll save this. We'll compile our program. And if we run it, we get an area of 200, which is correct. Now what's pretty neat is that we can also use this same macro with doubles. So for example, we could say double base 2 is equal to 10.5, double height 2 is equal to 5.2, double area 2 is equal to area, and we'll give it base 2 and height 2 as arguments. And then we could print out area 2. We'll say area 2 colon %f \n, and we'll output area 2. So if we save this, compile our program, and run it, we'll get area 2 is 27.3, which is also correct. And the reason this is pretty neat is that in contrast to regular functions in C, function-like macros are kind of like generic functions in that they can work with arguments of different types. And that's actually one reason why we may want to use function-like macros. Another reason to use function-like macros is that they eliminate the overhead from calling a function, because all that's really happening is text replacement. So for example, if we compile this program again using the E option, and we check out what the code looks like after the preprocessor is run, we see that in the case of computing the value for area 1 and area 2, all that's really occurred is text replacement. So we could say that the computation of the triangle area occurs inline. It occurs right in the expression itself, as opposed to calling a function to perform the area computation and then have that function return the results. To do that involves some overhead. We'd have to have a function defined that can compute the area and return it. So something like this: int area, int base, int height, and the function could return 1/2 the base times the height. Now having our program call a function like this is going to involve some overhead. In other words, some extra work that needs to be done. So for example, if here we had area and we passed in the arguments base 1 and height 1, one of the things that would have to happen is these parameters here would have to be created somewhere in memory. They would have to be set to these values here that are passed in, 20 and 20, in the case of base 1 and height 1. And there's more work that has to be done involving memory when a function is called. But without getting into it too much, basically, when we use a macro, we're avoiding that overhead. We're just directly performing the computation with the variables right in line. Now I should mention that it's possible to request that the compiler make a regular function an inline function that will have a behavior much like this, using the keyword inline. It's also possible that the compiler will decide to make that optimization on its own. But if we use function-like macros, we will get this behavior. Now another thing we can do with function-like macros is have a function-like macro use another function-like macro as an argument. So for example, if we say here, number define min x and y, and we're going to return the minimum number between x and y. We'll do a check here. If x is less than y, we're going to use the ternary operator. So if x is less than y, we're going to return X. Otherwise, we're going to return Y. That's the way the ternary operator here works. If this condition is true, this value is going to be the result of the expression. If this condition is false, this value is going to be the result of the expression. Now, keeping in mind that these function-like macros are really a sort of text replacement operation, what we'll do is surround this expression with parentheses, in other words, brackets, to give it higher precedence. Now we'll try using this min macro. So we'll say int min num is equal to min, and we'll put in 2 and let's say 7. Then we'll print out the min num. So we'll say printf min num colon %d \n, and we'll output min num here. So we'll save this, compile our program, and then run it, and we get a min num of 2. Now we can also use the min macro as an argument to the min macro. So for example, we could say here min 6 3. And if we save this, compile our program, and run it, we'll get min num 2. And this works. We could also say here min 8 and 1. We'll save this, compile our program, run it, and now the min num is 1. Let's use the -e option to look at the source code after the preprocessor has run. So we'll compile the program, and then let's check out the source code. So we'll scroll down here, and here's where we have the min num variable being set. And if we scroll over, there's this very large expression here. So that's why it was very important that we put the brackets around the expression in our macro. If we didn't do that, then we couldn't guarantee that each expression would actually evaluate before being used as part of some larger expression. If we want to print out a string as part of a function like macro, there's a couple things we could do. We'll make a macro here called output. We'll say number define, output, and we'll have S1. We could use a printf with %s, and then here we'll have S1. And we'll just put a new line here as well. Let's try out this macro. So down here, we'll say output, and first we'll try the string literal ABC. So we'll save this, compile our program, and run it, and we get ABC. We could also give a character array as an argument here. We could say car string is equal to, and we could have the string test2 here. And then we could supply string here as an argument. And if we save this, compile our program, and run it, we get test2. Now let's say we have two parameters. We'll have S1 and S2. And S2, we're going to print out. We'll have some space here, middle, and a space. And let's say we want to output S1 right here, like this. Because let's say we know that S1 is going to be a string literal. And so we don't want to bother using printf to actually insert it into the string. We could try this. We could try to put here test1 as a first argument. If we save this, compile our program, and run it, we get S1 middle test2. So the preprocessor is not going to do anything here. It knows that this S1 here is part of the string, and it's not referring to this parameter here. Now we can use the number sign operator, sometimes called the stringizing operator, to achieve the same effect. If we say here, number sign S1, so the number sign operator will turn the parameter it's given into a string literal. It will also concatenate together these two string literals that are now next to each other. So in the case of S1, it's already a string literal, so we might get a funny effect here. Let's save our program, we'll compile it and run it, and we get test1 middle test2. And test1 here has quote characters around it. And that's because it already was a string literal. So for example, we could just say here, test1. And if we save this, compile our program, and then run it, we get test1 middle test2 without the quotes. Because basically, the number sign operator is going to turn whatever this is into a string literal. We can also have function-like macros with multiple lines. So for example, let's make a macro to find the largest element in an array. We'll say number defined, find max. We'll accept two parameters, the array and the length. Now to put this on multiple lines, we're going to do a couple things. We're going to have here open bracket and open squiggly bracket, and we're going to put this backslash character at the end of each line. So we're going to use the typical algorithm to find the largest element in the array. The first thing we'll do is set a variable current max equal to the first element in the array. So we're going to start off with the assumption that that first element is the largest element in the array. Then we're going to loop through the remaining elements, and every time we find one that's larger than the current max, we're going to set current max to that element's value. And we're going to have this backslash character at the end of every line. Here we'll say for int I is equal to 1, I is less than length, I++, and then we'll have backslash at the end of this line. Now we'll do the check. So we'll say if the array at index I is greater than the current max, we found a new largest element. And if that's the case, we're going to update current max. And we're going to set it equal to this array element. Then finally, we're going to have current max here, semicolon. And just like our other function-like macros, there's no return here, because really what's going on is text substitution. We haven't actually defined a function, even though we're going to be using it a fair bit like a function. Let's try it out now. So down here, we'll make an array. We'll say int underscore array, and we'll have the elements 3, 5, 2, 1, 8, 3, 2. So we have 7 elements in the array, and 8 is the largest element in the array. Now we'll try using our macro. We'll say int maxint is equal to find max, and we'll give it int array and 7. Then we'll try to print out maxint. So we'll say printf maxint %d\n, and we'll output maxint. So we'll save this, compile our program, and run it, and we get maxint is 8, which is correct. Now we said that one of the advantages of using function-like macros was that they could be generic. But right now, we have here int current max. So right now, we're really assuming that this array is going to be an int array. We can make this more generic by using type of. So if here we say type of the array element at index 0, this will give us the type of the elements in the array. And now it's going to be more generic. Now we could actually use a double array with this function-like macro. So for example, down here, we could say double array is equal to, we'll put in 9.3, 2.4, 10.2, and 10.9. We'll use our macro now. We'll say double max double is equal to find max, and we'll give the double array, and we'll give the length, which is 4. Then we'll print out the max double. So we'll say max double %f \n, and then we'll output max double here. So we'll save this, compile our program, and run it. And we get a max double of 10.9, which is again correct. So there are some disadvantages to using function-like macros compared to regular C functions. We've already seen how function-like macros are expanded by the preprocessor, which is going to have the effect of making our compiled code larger, because the same code is potentially inserted in multiple places throughout a program, instead of a function which appears only once. Because function-like macros are expanded, the error messages that the compiler gives us might be difficult to understand. We also can't have a pointer to a function-like macro like we can a regular C function. We also need to be careful when passing arguments to a macro, as a macro may evaluate its arguments more than once, which can cause very difficult to understand errors. Let's go over an example of this. We'll make a global variable called number. We'll say int number is equal to 0. Then we'll make a function to increment this number and return the new number. So we'll say number plus plus and then return number. Then we'll create a function-like macro that prints out a number 3 times. So we'll say number define print number 3 times num. And what we'll do is just use printf to print out this number 3 times. So we'll say printf number $%d\n, and we'll output the number, and we'll copy and paste this, and we'll print it out 3 times. And we have to put the backslash at the end of each line here. So we'll save this, and now let's try using this function-like macro. But we'll provide an argument that will make things a bit of a challenge. We'll create a variable, int num. Then we'll use our macro. We'll say print number 3 times, and we'll say num is equal to increment. Now what we might think would occur is that the increment function would run. It would increment that global variable number to 1. 1 would be assigned to num here, and this assignment operation would evaluate to whatever is assigned to num. So in other words, this whole expression here would then evaluate to 1, and 1 would be passed to the print number 3 times macro. But that's not how macros work. We'll save this, we'll compile our program, and then we'll run it, and we get number 1, number 2, number 3, instead of the number 1 being printed 3 times. And what's happening here is that macros do text replacement. They are not regular C functions. And we need to remember that if we ever pass in arguments like this that involve expressions or assignments and things like this. Let's actually look at the code after the preprocessor is run. We'll say gcc -e -od and d.c here. And if we look at what happens with our code here, we can see that as the macro is expanded, we get the expression num is equal to increment repeating each time as an argument of those printf function calls. And the problem is the increment function is being called 3 times. Our number increments 3 times. What we really need to do is evaluate the number before we use it as an argument inside of these printfs. So here we'll say int num e is equal to, and we'll put num in brackets to force it to evaluate before assigning the result of that evaluation to num e. Then we'll output num e instead, the evaluated number. So we'll save this, we'll then compile our program, and we'll run it, and now we get number 1, number 1, number 1, as expected. So if we're going to use function-like macros, we need to always remember that really what's going on is essentially a text replacement operation. Otherwise, we can run into bugs that might be hard to figure out, like this one. So this has been an introduction to function-like macros in C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.